Jay is an assistant professor at UMass Amherst. He studies the application of computing tools to measure and manage infrastructure in industrialized and developing regions, include energy and building systems, transportation, water, and sanitation systems. His talk will be about opportunities for energy data analytics to enable sustainable growth in Sub-Saharan Africa. So Jay, the floor is yours.
Thank you, Abel, and thanks to Noman and the organizing team for putting together the workshop and the invitation to speak today. First, thanks also to Kyle. I think you teed up this talk very, very well, and I've long appreciated your research and how it's contributed to understanding global energy systems. So today I want to present more of a call to action for our energy data analytics community to think about how we can particularly focus our research on a region of the world that is frankly the least developed region, least economically developed region in the world that is facing some significant challenges. This is joint work with a PhD student of mine, June Lukuyu, who is also graduating this year and is actually going to become an assistant professor at the University of Washington starting next January. So very excited. And June's presenting a paper in the main conference on these kinds of topics later this week. So today I want to look at two main questions, and ideally with a focus on the Sub-Saharan African region, understanding why development in that region is different than it has been elsewhere. And it's not necessarily to make this a competition by any means, but just to understand the frame of the challenges and why this particular region needs somewhat different solutions. And then to focus in on our community, our research community, and where there may be opportunities to ameliorate some of the societal development challenges that are present in this region. So first, as some background here, this is 10,000-foot view. We have a huge growing region. Africa right now is about 1/6 of the world's population, and it's going to account for half the world's expected population growth in the next 30 years. So this region is changing massively, and they're starting from an exceedingly low economic base. There's a Bill Gates line that essentially is the per capita electricity consumption in Sub-Saharan Africa today is roughly the same as it was in the 1970s. And so you have these twin forces of population growth and development kind of fighting against each other in some ways. That's a statistical quirk, but it ends up essentially that you have huge communities without electricity access and other communities that have gained electricity access but simply aren't growing their consumption. So focusing first on this idea of what the existing economic position is of the continent and understanding how electricity access compares. So our team has done a lot of work in collaboration with a number of electricity utilities. This is in particular focusing on the East African country of Kenya, but we've also looked with the utilities of Rwanda and Uganda. Looking at rural electric consumption. So this is household level electric consumption. And as customers are being newly connected, this is a monthly electricity access or monthly electricity consumption among customers. And what we see is that as we move from older, now more well-established customers to connecting increasingly newer customers, we both are ending with lower monthly electricity consumption as well as reaching that peak sooner in the evolution of those customers. And the forces that govern this are not terribly surprising. As you reach further out into hinterlands and you reach customers who are more limited in their economic potential initially, they're going to consume less electricity. But the challenge is this growth pattern. This growth pattern, not just petering out, but in some cases actually starting to decline after years of connection is really, really troubling, and doesn't point to not just healthy livelihoods for those customers, but also the institutions that provide those customers with electricity really face challenges. Just for context, I want to look at this axis. we're talking about 20 to 30 kilowatt hours per month. Typical numbers in the US region are around 1,000. Typical numbers in China and Europe are around 500. So we're already at a fraction of consumption in these regions, as we see it in industrialized economies, and we're not necessarily seeing growth. And as just for some context, this is 10 cents a kilowatt hour for electricity, so it's purely raw economic power that isn't necessarily present in these settings. Now, this is rural economies. Obviously, rural economies are almost always the ones that are most troubled. If we think about non-residential electricity consumption, so this tries to understand how regions have evolved over time from being low electricity consumers to higher electricity consumers. And the target one here, the target comparison, is typically with South Asia. India, Pakistan, Bangladesh have developed much more substantial manufacturing bases that have allowed them to grow electricity consumption over time, as they've also evolved on expanding access to electricity, whether that's by community or by individual households. In most regions of the world, access to electricity is now near universal, if not universal, as it is in many of those regions, except for Sub-Saharan Africa. And what's important to understand is that Sub-Saharan Africa is at an inflection point where this is an opportunity to, as there's a lot of global investment in expanding access, we need to also think about what does it mean to grow non-residential electricity consumption? How do we grow commercial consumption? How do we grow industrial consumption, not just for the sake of growing consumption, but for the sake of growing economies and improving livelihoods? And this is a global challenge, but has great opportunities for our research community to focus on how the energy transition can actually allow these opportunities to not just produce climate-friendly technologies, but also development-friendly, societal development and economic development-friendly technologies for Sub-Saharan Africa. And so focusing on these aspects, thinking about how this development needs to happen during the energy transition as we move from fossil-driven energy to renewables and carbon-free sources of electricity and energy, makes this challenge increasingly harder. Whereas many other regions have developed with the cheap and abundant energy that fossil fuels provide, arguably cheap, and Africa is trying to develop at the same time, but also is trying to do this with renewables whenever possible. And being primarily equatorial is also facing some of the worst effects of climate change already today, and frankly has to adapt on the fly to some of those changes. So it's a daunting set of challenges, but we have lots of fantastic technologies that can contribute to better management in this space. And Kyle's presentation just before kind of highlighted a set of these, particularly on the remote sensing side. But that also, if we study the African continent in particular, we start to understand how it's not just impoverished economies. It's particularly there isn't necessarily an infrastructure base to grow from. Most electricity systems, road systems, even agriculture systems are highly fragmented, are poor performing, and there's lots of need for improvement in performance and expansion of those systems. But at the same time, while there is poor access and poor governance of those systems, there's also a tremendous opportunity to explore new models, to try out different technology, business, policy models, because the existing systems are largely underperforming. And so we see a lot more appetite for satellite data-driven system planning, much like Kyle just presented. A lot more opportunity to consider mobile first or even mobile only interaction with infrastructure services. For example, a number of countries on the continent have a majority of residents that use mobile money, and mobile money being a a system for financial flows actually enables a lot of cool technology on infrastructure delivery, whether it's energy systems or water systems or sanitation systems. And so there's really neat new technology opportunities in kind of how people interact with their infrastructure systems. And also with those kind of yawning gaps in measurement or management of those systems, you really have a different set of opportunities for incorporating Internet of Things approaches and embedded systems devices, along with ML approaches for working with institutional data or working with satellite data or working with the data from these IoT and other embedded system deployments that might not reach the same level of performance as you get in an industrialized context, where you can take the sensors that are already in place and improve their performance by 10, 20, 30%. But in fact, here where there's a very limited sensing base, just by providing that inference or that small amount of insight into system operation or how people use these infrastructure services, you can expand the performance by a larger factor, even if you don't end up at the same level of system performance overall. So really the opportunity for IoT and ML in Sub-Saharan Africa is it presents a larger opportunity from a proportional improvement perspective than we get in a lot of industrialized settings. So I've got 3 slides on different methods for our different opportunities for our community to contribute. And this is kind of the call to action portion of my presentation today. So one, I think this dovetails very closely with what Kyle presented, essentially thinking about where there's opportunities to provide better data and improve measurement that can be used by policymakers, by economists who have a lot of experience in developing regions work. While economists are very deeply experienced in this setting, they're often not they're not as sound on incorporating newer measurement techniques that our community has pioneered with ML methods, with working with institutional data, things like that, and predictive techniques. And so that's where there's really an opportunity for our community to contribute to sustainable development in this space. So that's measurement of access and consumption, that's reliability, location of energy infrastructure, a lot of this work that can be done with remote sensing methods. And then there's some work that requires more on the ground deployments, thinking about adoption, usage, and growth patterns of all kinds of the different technologies that are emerging now. Things that aren't as common in industrialized settings, electric cooking, two-wheeler vehicles, things like that are more specific to developing regions. And also we see a very different growth pattern for residential solar. As an example, the kinds of systems that flourish in developing regions are typically 5 to 10 watt or 20 or 40 watt systems, not the kilowatt scale arrays that we can necessarily see from satellite data, but really thinking about much smaller systems that are meant for small residential loads. And also, what does that scale down to very small scale do for energy storage? There's lots of opportunities to understand those patterns and partner with companies and donors and governments who are trying to adapt those technologies for these developing regions. On another front, there's also the particular understanding of what's happening in reaction to shocks. And so the COVID-19 pandemic has produced a groundswell of research to understand how economic activity has changed during repeated shutdowns and other economic shocks. This is largely done by satellite work, but there's also lots of surveys and other techniques there. But the effects of climate change are already strongly being felt in a lot of African countries. And so understanding how that's going to alter economic activity and better assessing that relationship. Another broad area is understanding how technologies developed elsewhere can fit in African contexts. NILM for understanding household loads, building occupancy sensing when you only have mobile devices and you don't have necessarily the same infrastructure around them. Thinking about energy storage's role in developing regions and how it might be different from how it's been used in industrialized regions. Particularly thinking about electric vehicles as a huge opportunity. These countries are not just growing in population, but also growing in motorization, and there's tons of opportunities to really arrest growth in carbon in these settings before it happens, rather than just converting like we are in a lot of industrialized settings. And so those are fantastic opportunities for our community to provide examples and leading lights for how these new technologies might be adopted and adapted for energy system transition in African contexts. Last opportunity I'm going to highlight is particularly, we depend in so many contexts on huge volumes of ground truth data. And while there are techniques to limit that with semi-supervised learning and one shot or few shot learning and other methods to learn on the fly, we are still likely to depend on substantial amounts of ground truth for many different techniques that our community employs. And so improving the performance or improving the efficiency of that data collection has substantial value. So that can be automating label collection with different kinds of vehicles. This can be improved IoT and other sensing methods for and mobile-based methods for understanding energy systems. This can be even going to the gold standard that economists still use, which is heavily based on survey data collection. There's ways to improve the efficiency of that data collection, the targeting of where surveys are conducted, and frankly, just the quality of the data from survey data. These are opportunities for our community to push forward research that can lead to development. There's a much tighter loop from research to deployment when there aren't massive institutions as gatekeepers, as we often see in industrialized regions. And so in total, the message I want to get across today is that our community has developed a huge groundswell of impactful methods, and there are ways that those methods can really contribute to sustainable economic development on the African continent. The continent has a lot of challenges, but also a lot of opportunities, and I'd be excited for our community to engage more deeply with research in Sub-Saharan Africa. So last, I want to say thanks to particular collaborators whose work I referenced here: Simone Fobi and Vijay Modi from Columbia, my PhD student June from UMass, and collaborator Samson Ondiek from Kenya Power. Thank you very much.
Thank you, Jay. Do you have any questions to Jay? Okay, I have one question. Like, it seems that the growth in energy demand in the region will be exponential in the future. But what do you think will be needed to actually deploy the solutions you just presented in this specific region of the Sub-Saharan African countries?
Sure, it's a good question. So one would hope that unperturbed we would see exponential electricity consumption growth, but that's precisely not what we're seeing. We're seeing growth really level out, and this is a combination of limited economic activity and just less. It's more of infrastructure provision without the societal scale provision of other services, other education, other methods that can improve adoption of electricity as an energy source. And so there's need for that kind of cooperative infrastructure to gain adoption. There's need for successful experiments, successful deployments of electric vehicles, of energy storage, and showing how those can be used in these contexts, in ways that are unique. Understanding that energy storage can be used for improving reliability for particular customers rather than used at kind of grid scale like it's used often in industrialized regions. So we have a lot of the same technologies, but we have to figure out how they might adapt to the setting and how they can grow for given the constraints of these settings that might be different than what we see in industrialized regions.
I have one question for you. So while these technologies are generally not that compute intensive, at least in terms of like you are getting data from mobile phones and things like that, but when you build applications on top of these like data sources and try to make people like sort of adopt them, there will be a lot of need for cloud computing and relevant or at least edge computing and things like that. How do you see that these solutions would drive the growth of edge computing, cloud computing technologies in that region?
Great question. So, from a cloud perspective, we have started to see data centers pop up throughout the continent. We see a lot of undersea lines and things like that. So latencies for cloud deployments, while they are a challenge, they are far less of a challenge than they used to be. And so while it's nice to have cloud resources available locally, it's typically not, from my perspective, hasn't been a big challenge for once there is that connectivity to the cloud. Edge computing, a very different one. So edge computing, where we have kind of weaker and more expensive internet access in a lot of these settings, becomes a lot more valuable because you could do computing on the smartphone. And frankly, smartphones are a huge step forward for Africa. It's kind of the opportunity to get sensing and compute and communication all in your pocket at that kind of scale, going from what was otherwise a fairly limited data infrastructure, enables a lot of new applications that weren't considered. Now, here we layer on our smartphones to an existing kind of vast ISP and computing network otherwise, but in a lot of sub-Saharan African settings, smartphones are the game. That's where the bulk of the computing is available. And so rethinking applications that are edge computing first and edge computing only is a great opportunity for our community to think through, like, well, how might we deploy similar or alternative services where the edge computing paradigm is the only one we have.
I think Kyle has a question.
Absolutely. And Jay, thanks as always for a wonderful presentation. I always learn a lot whenever you share. And one thing that comes to mind, I think you built a great network of local and community partners and organizations in the field. As you're thinking through the topics that you shared today, what are the big needs that are being shared by those community partners, by organizations on the ground? What are like the top two items that come up in those discussions that I'm sure are motivating a lot of your work anyway, but just curious about that.
Sure, great question, Kyle, and thanks for the kind words. I'd say that one is there is a lot of pressure in Africa for even research efforts to have a tighter loop to economic sustainability. So when I would guess that when most of our community thinks of sustainability, we think of carbon from a carbon perspective. But in a lot of African settings, there isn't as much the luxury to think only about carbon. These systems have to point very clearly towards how do we how do we make money? How does X pay for itself? So we've done work looking at the deployment of electric boats for fishing communities and understanding how that can both be cheaper for fishing boat operators and fishing boat owners, as well as allows the mini grid company that provides their electricity to sustain and kind of have that core set of users. It's actually kind of a supplementary goal that you don't use diesel in those settings and you end up moving to electricity that's coming from renewable sources. So I'd say one is having that closer connection from even research towards where does the money come from for this? How does it save, for whom does it save money and how? And second, at least from a research perspective, demonstrations are pretty crucial. It's a large leap between a research paper and a working system that is out there. And as much as our goal is novelty and showing new methods, those things are valued by our conferences and our journals, but not necessarily valued when it comes to actual impact in the world. And so sometimes that means sort of balancing our goals towards how do we get these things actually built and used, and that introduces new sets of challenges that can inform future research. But systems work is laborious. It takes a lot of effort to actually not just build the thing, but also build the thing in a way that the partners can gain value from it. And so that one is somewhat of a broken record concern for research, and it's hard to bridge that gap because our incentive systems aren't necessarily built in such a way, but it comes through again and again. You hear collaborators, partners say, okay, but the last researcher I worked with wrote their paper and ran off. And that's a kind of long built reputation from our community. And how do we start to repair that when economic impacts and people's livelihoods are on the line?
That's a great.
So I would like
so
to
much.
just add a comment how like the last couple of comments from Jay tie really well to an earlier talk that Dr. Naveed Arshad gave on his perspective of climate change impacts in Pakistan, and how simple word of sustainability can mean very different things in developed countries and developing countries. And fortunately, we have Jay for a panel at 3 p.m. Eastern time. So if anyone has more questions, they can drop by. Like we will have Jay, David, and Minghua for an hour-long panel. And I think Abel can now move on to the final speaker of this session.
Thank you, Jay.